Hello, dear students. I received some complaints about electric force 03 video. The first 4 minutes doesn't have an audio, so these actually are two slides. I don't know the reason, but the audio is not there. So I'm gonna explain these two slides separately. So it could be less than 4 minutes, it could be more than 4 minutes, but the first two slides you can learn for the electric force 03 from here. Um, the electric force between two charges is estimated by Coulomb's law. So Coulomb's prepared this law for the forces between the two charges. So here you can see Q1 and Q2, they are positively charged, so they repel each other. When they repel each other, they exert a force. F12 is the force experienced by 1 exerted by 2, and F21 is a force experienced by 2 exerted by 1. So both repel each other. This force F12 or F21 is called the electrostatic force of repulsion. Similarly, Q2 is attracted by Q1 with a force F21, and F1 is attracted by Q2 with a force F12. So both attract each other. So this force of electrostatic attraction or electrostatic repulsion is given by the Coulomb's law. Coulomb's law explains that this force is directly proportional to the product of magnitude of the charges, means this one. So keep in mind, this depends upon the magnitude of the charges and inversely proportional to the square of distance. If r is the distance between the charges, then the force will be proportional to 1 over r square. This is called as inverse square law. So the force of attraction or repulsion between two charges we can write proportional to Q1 Q2 divided with r squared. This we can also write as some constant called as the constant of proportionality, Q1 multiplied with Q2 divided with r square. This constant is represented with small k and called as Coulomb's constant. Its value depends upon the medium between the charges. So the mathematical form of the Coulomb's law is this, where Q1 and Q2 are the magnitudes of the charges involved. R is the distance. In vector form, we can write in this way. That's optional for you at the moment. So K is Coulomb's constant and its value is that much, which we usually approximate as 9 into 10 power 9 Newton meters squared per Coulomb square. This value depends upon the medium, and this value of the K is for the free space. Free space means the vacuum. For air and vacuum, we take almost the same value. So in air, are in free space, the value of this k, which is called as the Coulomb's constant, is 9 into 10 power 9 Newton meter square per Coulomb square. Now we can see, if we find force F12 or F21, then I can write k, q1, q2 and square of the distance. Similarly, F21 is also k, the magnitude of the charges involved. So you can see these two forces are exactly equal to each other. They are also opposite. So you may ask a question that, can the forces in diagram above cancel each other? They are equal, they are opposite, but they don't cancel each other. And the reason is that these two forces act on two different objects. When these two forces act on a single object, then the sum of the forces will be equal to 0. So these two forces don't cancel each other because they act on two different objects. From now onward, you may follow the next video, that is um, electric force CO3. This I may name as um, part 1, and the next one will be renamed as part 2. Okay, I hope this will help you and solve your problem.